There's no strong reason behind this idiom, it's just the convention that has emerged, and folks have gotten used to reading and writing Rust code this way. The exception to this idiom is if we're bringing two items with the same name into scope with the use statements, because Rust doesn't allow that. Listing 7-15 shows how to bring two result types into scope that have the same name but different parent modules and how to refer to them. Standard format, standard IO. Snip do anything? No. As you can see, using the parent modules distinguishes the two result types. If instead we specified use standard format result and use standard IO result, we'd have two result types in the same scope and Rust wouldn't know which one we meant when we use result, providing new names with the as keyword. There's another solution to the problem of bringing two types of the same name into the same scope with use. After the path, we can specify as and a new local name or alias for the type. Listing 716 shows another way to write the code in listing 715 by renaming one of the two result types using as. In the second use statement, we chose the new name IO result for the standard IO result type, which won't conflict with the result from standard format that we've also brought into scope. Listing 715 and 716 are considered idiomatic, so the choice is up to you. Re-exporting names with pub use. When we bring a name into scope with the use keyword, the name available in the new scope is private. To enable the code that calls our code to refer to that name as if it had been defined in that code scope, we can combine pub and use. This technique is called re-exporting because we're bringing an item into scope, but also making that item available for others to bring into their scope. Listing 717 shows the code in listing 711 with use in the root module changed to pub use. Hosting. By using pub use, external code can now call the add to waitlist function using hosting add to waitlist. If we hadn't specified pub use, the eat at restaurant function could call hosting add to waitlist in its scope, but external code couldn't take advantage of this new path. Re-exporting is useful when the internal structure of your code is different from how programmers calling your code would think about the domain. For example, in this restaurant metaphor, the people running the restaurant think about front of house and back of house, but customers visiting a restaurant probably won't think about the parts of the restaurant in those terms. With pub use, we can write our code with one structure but expose a different structure. Doing so makes our library well organized for programmers working on the library and programmers calling the library. Using external packages. In Chapter 2, we programmed a guessing game project that used an external package called rand to get random numbers. To use rand in our project, we added this line to cargo.toml. Rand equals quotes 0.8.3. Adding rand as a dependency in cargo.toml tells cargo to download the rand package and any dependencies from crates.io and make rand available to our project. Then to bring rand definitions into the scope of our package, we added a use line starting with the name of the crate, rand, and listed the items we wanted to bring into scope. Recall that in generating a random number section in Chapter 2, we brought the RNG trait into scope and called the rand thread RNG function. Members of the Rust community have made many packages available at crates.io, and pulling any of them into your package involves those same steps. Listing them in your package's cargo.toml file and using use to bring the items from their crates into scope. Note that the standard library std is also a crate that's external to our package. Because the standard library is shipped with the Rust language, we don't need to change cargo.toml to include standard, but we do need to refer to it with a use to bring the items from there into our package's scope. For example, with hashmap, we would use this line. We'll bring that in again. Feel like I'm learning Java again. Using nested paths to clean up large use lists. If we're using multiple items defined in the same crate or same module, listing each item on its own line can take up a lot of vertical space in our files. For example, these two use statements we had in the guessing game, in listing 2.4 bring items from std into scope. Let's see if we can guess how to do this. I did it. Nice. Instead, we can use nested paths to bring the same items into scope in one line. We do this by specifying the common part of the path, followed by 2 colons, and then curly brackets are in a list of the parts of the paths that differ, as shown in listing 7-18. Specifying a nested path to bring multiple items with the same prefix into scope. In bigger programs, bringing many items into scope from the same crate or module using nested paths can reduce the number of separate use statements needed by a lot. We can use a nested path at any level in a path, which is useful when combining 2 use statements that share a subpath. For example, listing 7-19 shows 2 use statements, one that brings standard IO into scope and one that brings standard IO right into that scope. You bring self in there, okay. The common part of these two is standard IO, and that's the complete first path. To merge these 2 paths into one use statement, we can use the self in the nested path as shown in listing 7-20. The line brings standard IO and standard IO right into scope. The glob operator. If we want to bring all public items defined in a path into scope, we can specify that path followed by the star, the glob operator. This use statement brings all public items defined in standard collections into the current scope. Oh, it's lowercase. Into the current scope. Be careful when using the glob operator. Glob can make it harder to tell what names are in scope and where a name used in your program is defined. The glob operator is often used when testing to bring everything under test into the test module. We'll talk about how that works and how to write test section in chapter 11. The glob operator is also sometimes used as part of the prelude pattern. See the standard library documentation for more information on that pattern. Separating modules into different files. So far, all the examples in this chapter define multiple modules in one file. When modules get large, you might want to move their definitions to a separate file to make the code easier to navigate. For example, let's start from the code in listing 717 and move the front of house module to its own file, source front of house rs, by changing the crate root file so it contains the code shown in listing 721. In this case, the crate root file is source librs, but the procedure also works with binary crates whose crate root file is source main rs. Using a semicolon after mod front of house rather than using a block tells Rust to load the contents of the module from another file with the same name as the module. To continue with our example and extract the hosting module to its own file as well, we change source front of house to contain only the declaration of hosting module. The declaration, okay. Then we create a source front of house directory and a file source front of house hosting rs to contain the definitions made in the hosting module. So source front of house rs. Then we create a source front of house directory. The module tree remains the same. And the function calls an eat at restaurant will work without any modification, even though the definitions live in different files. This technique lets you move modules to new files as they grow in size. Note that the pub use create front of house hosting statement in source librs also hasn't changed. Nor does use have any impact on what files are compiled as part of the crate. The mod keyword declares modules, and Rust looks in a file with the same name as the module for the code that goes into that module. I'm stumped. Oh, because this got fucked up. Okay. There we go. Just a minor naming issue. Summary. Rust lets you split a package into multiple crates and a crate into modules so you can refer to items defined in one module from another module. You can do this by specifying absolute or relative paths. These paths can be brought into scope with a use statement so that you can use a shorter path for multiple uses of the item in that scope. Module code is private by default, but you can make definitions public by adding the pub keyword. In the next chapter, we'll look at some collection data structures in the standard library that you can use in your neatly organized code. Okay, so let's kind of review this. This is librs. And that's in a file called front of house. And that has a module hosting that just is in that directory. What if we do pub mod hosting? We have to go hosting. Okay, so the file itself is the module. Okay, pretty cool. Sweet.